Hello, students. Good afternoon. How are you doing? Today we'll be dealing with the topic forces and motion. So the subtopic we'll be dealing with is lift off. Now, to propel a giant space shuttle into space, it takes an enormous force. When a spacecraft accelerates upwards, the crew are pressed firmly back into their seats. This is how they know that their spacecraft is accelerating. So let's try these drag the words. The unit of force is the, let's say, newtons. So 1 Newton is equivalent to 1 kilogram meter per second square. Examples of the sizes of the various forces are force required to lift, let's see, can it be leg muscle, can it be apple? Apple now is approximately 1 Newton. To jump into the air, the leg muscles provide a force of about 5,000 newtons. Provided the engine to be able to accelerate forward. A Boeing 77 jumbo jet, that is an aeroplane, requires a thrust of 500,000 newtons from its 4 engines. So let's check and see. That's good. Moving on. So some important forces. Let's talk about weight. The weight of an object is the pull of gravity on it. Weight always acts vertically downwards. Contact force. This is the force that occurs when two objects touch. This force helps humans from falling through the floor. Friction. This is the force that opposes motion. It acts in an opposite direction. Air resistance or drag. This is the force of friction when an object moves through air or water. Upthrust. This is the upward push of a liquid or gas on an object. We should note that force produces acceleration, deceleration, and a change in direction of an object. Force can also be represented with an arrow since it's a vector quantity. It has magnitude and direction. Now, let's do some little activity. Force is a scalar quantity. Can that be true or false? Let's check. False. Because force is a vector quantity, it has magnitude and direction. Yes. Which of these units is related to force? We have gram per centimeter. Gram per centimeter is related to density. Kilogram per second. This is not related in such a way to any quantity. Newton meter. Then we can talk about some other quantity. Then Newton, that is the force of that's the unit of force, as we can see. Now, in which of the following is resultant force needed? A car moving in a straight line at a steady speed, a car changing direction, a car speeding up, or a car slowing down. When a car is slowing down, it is undergoing deceleration. When a car is speeding up, it is undergoing acceleration. And when a car changes direction, the force of the car also what? Changes. The acceleration of the car also changes. So a body will undergo resultant force when a car is moving in a straight line at a steady speed. That is the balancing of forces moving and the one trying to push it backwards. Let's see. Correct. Now, two or more forces. The combination of two or more forces results in a resultant force. Let's see the example we have below by studying this diagram. In A, we have air resistance, which is 400 Newton. And we also have the force on the push of engine, which is 600 Newton. Looking at B below, we have the force on the engine, 600 Newton, and the air resistance at the back of the car, also 600 Newton. This has something to teach us. The force of push on the engine is 600 Newton, while that of drag, air resistance, is 400 Newton. From A, that shows that the resultant force is then obtained as force of push minus the drag force, which is 600 minus 400, all in Newton, gives us 200 Newton. This resultant force will make the car accelerate to the right, where the drag force is 600 Newton. And also the force on the engine also is 600 Newton. That will be 600 minus 600 Newton. That gives us 0 Newton. This shows that the car will not accelerate but continues at a constant speed in a straight line. Now let's deal with this activity. Which statement is correct? From the knowledge of what we've been able to go through just in some few moments ago. The weight of the bottle of water is one of the forces acting on it. The mass of a bottle of water at the North Pole is different from the mass at the equator. The weight of a bottle of water and its mass are the same thing. The mass of a bottle of water is measured in newtons. Looking critically to these options, let's deal with them one after the other. The mass of a bottle of water is measured in newtons. Mass will always be measured in kilograms, so the statement is incorrect. The weight of a bottle of water and its mass are the same thing. Nope. Why? Because weight is measured in newtons, while mass is measured in kilograms. The mass of a bottle of water at the North Pole is different from its mass at the equator. This is not so because mass is constant, mass of a body is constant on all points on the Earth's surface. Now, the weight of the bottle of water is one of the forces acting on it. Yes, because weight will always act downward. So the weight on the water is one of the forces acting on it. Let's see. Correct. Now, what is the gravitational force the Earth exerts on an object? Looking at the options, we have the density of the object, the weight of the object, the mass of the object, and the volume of the object. The density of an object is the mass per unit volume. So it has no relation with gravitational force. The mass of an object deals with the quantity of particles that it has. So it has nothing to do with gravitational force. The volume of an object also has to do with its length in terms of length, breadth, and height. While the weight of an object will always be acted upon by forces, so far the object is positioned on the Earth. So the gravitational force the Earth exerts on an object is also the weight of the object. Looking at this statement also, below are 4 statements about the effect of forces on objects. 3 of the statements are correct. Which statement is incorrect? The force acting on an object is the product of its mass and acceleration due to gravity. Yes, force is equal to mass times g. G is the acceleration due to gravity. A force can change the mass of an object. No, because mass on its own is a constituent of what? The constituent of force with the application of acceleration due to gravity. A force can change the shape of an object. Yes, it can bend, it can twist, it can compress it. A force can change the length of an object. Yes, it can shorten it, it can elongate it. So a force can change the mass of an object will be the right option. Let's see. Correct. So with that, let's proceed. So in summary, we are to choose the correct statement. Weight of an object always acts vertically downwards. Yes, correct. Weight of an object always acts vertically upward. No, that would have been upthrust. Weight of an object do act horizontally across a platform. The statement is wrong. So the correct statement will be that weight of an object always acts vertically downwards. Now we've come to the end of this class. Do subscribe to www.edubbey.com for more of our interactive books. I would also like you to watch our interactive classes from time to time. Do have a great time. Bye.